Okay, so what we're going to do now is we're going to move on to what I call two-step equations. Okay, in these equations, we are going to have to do both add an inverse and multiply an inverse. We have to do both of them. Okay, whenever we have to do both, whenever we have to add an inverse and multiply an inverse, unless there are parentheses, I typically begin with the addition first. So we're going to get rid of this first, and then after this is gone, we're then going to get rid of this, and then the x will be isolated. It will be by itself. Okay. So let's go ahead and begin with eliminating the 375. The inverse of positive 375 is negative 375. And so what we're going to do is we're going to add negative 375 to the left, and then we're going to similarly add negative 375 to the right. Now I want to remind you that we normally don't write it as add negative 375. Typically what we do is we just write minus 375. So I'm going to go ahead and do that. I'm going to change it to just minus 375 because practically speaking, that's the way that we do it, but we have to understand it as adding an inverse. So we're adding negative 375. On this side, it's going to cancel and become 0. We're going to bring down the 9x. So in two-step equations, after we deal with one thing, the other thing that we did not yet deal with, all we do with that is we just carry it down. We just carry it straight down as is, just like we carry down the equal sign. Now here, 482 minus 375, well, that's 107. You may need a calculator for that, but I want you to know it is 107. And so what we really have here is 9x is equal to 107. Okay? Then we're going to get rid of this 9. The 9 is being multiplied by the x. This is 9 times x. And therefore, to eliminate the 9, we have to multiply by its multiplicative inverse. So we're going to multiply by 1/9. And when we multiply by 1/9 on that side, we're also going to multiply by 1/9 on the right side. On the left, 1/9 times 9 equals 1. And so we have 1 times x is equal to, and then this over here is the same thing. Whenever we multiply a number, like if we have 5 times 2/3, anytime we multiply an integer times a fraction, we always multiply the integer times the numerator. And so this would be 10 over 3. Okay? So we're just going to multiply this 107 times the 1 up here. Okay? So 107 times 1 is 107. And so we have 107 over 9. And we wouldn't write the 1, so we would just write it as x is equal to 107 over 9. Okay? Let's try another example. Okay, we have another example here. This is 12/97, 12 over 97 times x minus 38 is equal to 13. And so we want to get rid of this. So we've got a multiplier, and we also have an addend here. We want to get rid of the addend. We want to get rid of the thing that's being added. So the inverse of negative 38 is positive 38. The additive inverse is positive 38. So we want to add positive 38, which just means plus 38. We're going to do the same thing to both sides, plus 38. On this side, it's going to cancel and become 0. On this side, it's going to become 51. We're going to carry down the equal sign. We're going to carry down this 12 over 97x. And now basically what we have is 12 over 97x equals 51. And so now, in order to solve this, we want to multiply by the multiplicative inverse of 12 over 97, which is 97 over 12. And we have to do the same thing over on the other side. Multiply by 97 over 12. On this side, the 97 over 12 times 12 over 97 is going to become 1. And so this is going to cancel. And we're just going to bring down the x. Now we have to multiply the 51 times the 97. I'm going to need a calculator for that. And so I'm going to go to a calculator, my Numworks calculator, which I like so much. I'm going to multiply 51 times 97. And that gives me 4,947. So this winds up being 4,947 over 12. And then what I'm going to do is I'm going to divide 4,927 by 12. I just want to see if it can be reduced. And it can, actually. It can be reduced to 1649 over 4. Now I'm not going to give you any that are this large on the little quizzes and on an exam. I just want to give you the idea that we can do this. Okay, so here x is 1649 over 4. And so I want to do now maybe just, okay, so here's something a little more normal. 2x minus 8 is equal to 6. We're going to get rid of the addition first. It's adding a negative 8 onto the 2x. So we have 2x plus negative 8. Okay, so we want to do the additive inverse of negative 8, which is positive 8. So we're going to add positive 8 to both sides. Positive 8 here, okay? And over here, we're going to have 14. The 8's are going to cancel, and we're going to carry down the 2x. Okay? And now we want to cancel this multiplying 2, so we're going to multiply by 1/2 on both sides. Multiply by 1/2. And here's another way of doing it. 2x times 1/2, we would multiply the 2x times the 1 in the top. We wind up with 2x over 2 is equal 14 times 1/2. 14 times 1 is 14 is equal to 14 over 2. And here we can cancel the 2's and we get x is equal to 14 over 2 is equal to 7. And so our final answer is 7. And so these are some examples of two-step equations.